Hey guys, Coach Brian talking about 1.4 notes, pairs of angles. So in 1.3, we talked about angles, what they are, how to name them, how to add and combine them. Talked about rays, bisectors, all that good stuff. Now we're going to be talking about special pairs of angles and ways that they can combine in ways that will help us further down the road as we get to more complex things. So the first thing, we need to talk about three special types of angles or pairs of angles: adjacent angles, vertical angles, and what's called a linear pair. And so this whole table is in your notes and it's completed, but really quickly, I'm just going to sketch this out. Adjacent angles are angles that are beside each other or next to each other, okay? Next to each other. And the really important things from the definition are that they are coplanar. Okay, that's important. They also share a vertex and a side. That's really important. They share a vertex and a side, but they also don't overlap. And that means they don't like cover or go into each other at all. They meet at that shared side, and it's kind of like a boundary for them. They don't pass it and overlap each other. So they are coplanar, they share a vertex and a side, and they don't overlap. Vertical angles occur when you have two lines that intersect. So these two lines cross each other, and if you look, because of that, they create some angles. I know I'm making my picture tiny, but in your notes, it's a little larger and easier to see. The important thing is that they are opposite of each other, opposite angles at an intersection. So they're the ones that are across from each other at an intersection. And then lastly, a linear pair, also from an intersection. Okay, so I have two lines that cross, they intersect, and these angles here that are on the same line, they form a straight line, all right? Those are a linear pair. Important thing about them is they are adjacent, which means next to each other. That's the first part. The next important part is that they make a line. And another way of saying that is that they add up to, when you take the two values of them, they add up to 180 degrees. Just a little review from 1.1. A postulate is a statement that can be accepted as true without proof, and a theorem is a statement that can be proven. Theorems, we're going to use them a lot later in class when we're proving things, and so they kind of build on each other, and you can use them as reasons to defend other theorems. The first one we're going to talk about is the linear pair theorem. So we just talked about up here what a linear pair is. Okay, a linear pair is two angles that are adjacent, and together they make a straight line. And so you can see, let's just say we have angle A and B here. We have two angles that are side by side. They share a vertex, they share a side, and together they make a perfectly straight line. So we would say that those are a linear pair. And we can actually figure out what these missing x's are, what these missing values are, by setting up an equation. And because we know that they're going to add up to 180, we know that these two angles together will equal 180 when I combine them. So if I just take those two values and add them together, they should add up to 180. And so the first thing I'm going to do is combine like terms. I've got 7x and 3x. Together, those give me 10x. And then I've got negative 46 and positive 6. I combine those, and that leaves me with negative 40. And now it's just the process of solving for x. So I'd add 40 to both sides. 10x equals 220. And then I would divide both sides by 10. So I would get x equals 22. And so that's what x equals. If the question said solve for x, you'd be done. If it said figure out what angle A is or what angle B is, you would plug in 22 for those missing values. And for angle A, you would get 108. For angle B, you would get 72. And if you add those together, just to check yourself, they do in fact add up to 180 degrees. The next theorem is our vertical angles theorem, which remember from our definition above, they are at an intersection and they're across from each other. And what we know about them is not that they add up to anything, but we know that they are equal. So I can actually take the first value and set it equal to the second. And I know that these two equal each other. So if I solve for x, I can plug it back in to either one of them and figure out what the unknown angle is. And so I like to take the smaller x and subtract it from the larger x. And in this case, that just leaves me 1, which is really nice because when I move this 2 over, sorry, I'm thinking ahead here, so let me undo that. When I add this 2 over, it leaves me with 27, so x equals 27. So if the problem said solve for x, I'd be good. If it said figure out what the angles actually are, I would add 27 back in there. And I don't have to do both of these. I could just to prove like, hey, they're equal. But I'm going off my vertical angle theorem. I'm going to presume that they're going to be the same. So if I do 5 times 27, I get 135. And I take away 2, that leaves me 133 degrees. And if you just wanted to check yourself, you could say 4 times 27 is 108 plus 25 is 133 degrees. Guess what? Those two angles equal each other, which is exactly what the vertical angles theorem says. All right. Now let's talk about complementary angles. Complementary angles add up to 90 degrees. That means they're going to form a right angle. Supplementary angles add up to 180 degrees. That means they're going to form what's called a straight angle or 180 degrees. Okay, so two 90-degree angles make a 180, but you could get this combination in any way. It could be 108 and 72. It could be 90 and 90. It could be 110 and 70. It could be 55 and 125. So there's a lot of different ways that you could make 180. But if two angles that are adjacent add up to 180, they're a linear pair and they are supplementary, and they're what we would call a straight angle. Over to the right is just some practice about angle relationships. I'll just do the very first one with you right here. It says RPQ and TPU. What is their relationship? So at this point, they are kind of formed by the intersection of all of these lines. And so when two angles are at an intersection and they're opposite of each other, I can use my vertical angles theorem and know that they're equal. Now in this case, it's just looking for type. So I'm just going to say that they're vertical angles. I know that they're at an intersection, they're across from each other, and they're equal. I want you to see if you can do B, C, and D on your own. The next one, it says A and B are complementary. That kind of key word right there goes back to our note on 5. They're complementary, so they add to 90. And it tells you that one of them is this. So you need to find the other. Remember that together they add up to 90. Next, it says two angles are supplementary. So again, going up to 6, supplementary, add to 180. This one's a little trickier. It says one angle is 12 less than twice the other angle. 12 less than twice the other angle. Find the measure of both angles. So that means I have two angles, all right? I'm just going to sketch them here. One of them is, an unknown value. The other is an unknown value, and this is what I know about them right here. I know that one of them is the other one times 2 minus 12. So see if you can solve that one. And then lastly, in examples 4 and 5, all right, for 4, you're using this image, and it's just a variety of angles formed by all these intersections. And there's a lot of helpful information in here, like just this little symbol right here lets you know that that's 90 degrees. And so that alone, you're actually able to, I'm not going to just tell you outright right here, but because you know that those two make a 90, you actually can then figure out what every other angle on the page equals, which is helpful. But it's just asking you to find vertical angles, adjacent, a linear pair, supplementary, and complementary. So I'll get you started with C, and I'll let you do the others. C says to list 2 linear pairs. So I'm looking for some angles that form a perfectly straight line. A good strategy for this is to find one of the straight lines and then see what angles make that up. And so I'm going to show you the easy way, and then I'll show you kind of a more, not complicated, but just not quite as straightforward. Right now, if I look at this line that makes 180 degrees, I can see that it's split right here. And so angles HMB and angle DMB make up that linear pair. That's one linear pair. Okay, that's just one. Another, I'm going to use the same line actually, the same line, HMD, or line HD. But I'm going to use some different angles for it. I'm going to use this line and this angle, and I'm going to use this line and this angle. So you can see together those make a 180 also. And so I've got angle HMA and I've got angle DMA. The bell always rings while I'm recording. So those are a pair of angles that equal 180 and another pair of angles that equal 180. So that's just your answer for C. I want you to see if you can do A, B, D, and E. And also try example 5. It's a little bit tougher. The angles are complementary. That's a key word. That should let you know something immediately. They have a ratio of 1 to 2, which means one of them is 2 times the size of the other. So see if you can find what they both equal. And that's all for 1.4 notes.